Hey everyone, and welcome to this explainer. Are you ready to absolutely demystify two of the most dreaded math concepts out there? Yeah, I'm talking about permutations and combinations. Look, if you're gearing up for Class 11 exams, JEE or CUET, I know these formulas can sometimes just look like this confusing, swirling blur of mathematical symbols. But don't worry, we are going to clear all of that up today. By the end of this explainer, you're going to see exactly how these concepts are really just elegant, clever ways of counting. We're going to lock this down in just 8 minutes, so let's get into it. To get us there, here is our game plan for today. We'll start with the magic of counting, then hit the fundamental principle and factorials. After that, we'll break down permutations, then combinations, highlight the key differences, and finally, wrap up with some crucial exam tips.
All right, part one, the magic of counting.
I want to ask you something directly. Seriously. What if every single permutation and combination question on your test suddenly just made sense? Imagine staring at a massive, complex word problem and instantly knowing without a doubt exactly which formula to pull out. It all starts when you realize that we aren't just doing abstract, pointless math here. We're actually building a foolproof toolkit for counting huge possibilities without having to sit there and list them all out one by painful one.
Because, counting isn't just theory. It's the hidden math behind the everyday systems we literally rely on all the time. Every single time you create a password, figure out seating arrangements, like making sure you don't get stuck sitting next to that one annoying cousin at a wedding, or look at lottery odds, pick players for a sports team, or spin a combination lock, you are interacting with permutations and combinations in the real world.
Let's move right into part two, the fundamental principle and factorials. We have to lay the absolute groundwork first. And the fundamental principle of counting is wonderfully simple. It basically says that if one event can happen in m ways and a second event can happen in n ways, the total number of ways both can happen is just m multiplied by n. And this brilliantly illustrates the concept. If you have 4 bus routes from point A to point B and 3 bus routes from point B to point C, you just multiply them. 4 times 3 gives you 12 total ways to travel from A to C. It is literally that straightforward. Now, to make multiplying these large sequences way easier, we use a super cool mathematical tool called the factorial. It's denoted by an exclamation mark. The factorial of a number n is simply the product of that integer and all the positive integers below it. This little exclamation mark is the absolute building block for everything that follows in this explainer. Let's actually visualize this for a second. If we want to calculate 5 factorial, we just multiply 5 by 4 by 3 by 2 by 1. Imagine you have 5 objects in your hand to arrange. For the very first spot, you have 5 choices. Once you place one down, poof, that object disappears from your hand, right? So that leaves you with 4 choices for the next spot, then 3, then 2, then 1. You multiply them all together and you get 120 possible arrangements. Boom, done.
Okay, shifting gears to part 3, permutations.
So the crucial point is that a permutation is an arrangement of objects in a definite order. Order is absolutely everything here. If you are arranging 3 students, let's call them A, B, and C, in 3 specific chairs, sitting them in the order A, B, C is a completely different arrangement than sitting them in the order B, A, C. The second you change the order, you've created a brand new permutation. And when you need to find the number of permutations of n objects, taking r of them at a time, you use this mighty formula right here. NPR equals n factorial divided by n minus r factorial. The numerator, that n factorial, gives you all possible arrangements. Then the denominator swoops in and cuts out the arrangements for the items you didn't even select. It's an incredibly efficient way to calculate exact positions. Which brings us to part 4, combinations. So if permutations are all about order, a combination is just a selection where the order is completely immaterial. It doesn't matter at all. Think about picking players for a cricket team. If you select players A, B, and C to be on your squad, it totally doesn't matter if you called out player B's name first or player C's name first. BAC, CAB, ABC, they all result in the exact same team running out onto the pitch. Order does not matter. Now, take a look at the combination formula, NCR, and compare it to the permutation one. It's almost identical, right? It's n factorial divided by n minus r factorial, but with one vital addition. We also divide by r factorial. Why? Well, because order doesn't matter in combinations, we use that r factorial to divide out all those redundant arrangements that represent the exact same group of people or things.
All right, let's lock this in with part 5, key differences.
Okay, let's dive into this side-by-side comparison because this is the ultimate conceptual bridge. Draw a hard line in your mind right now. On the left, we have permutation. Order matters. You're going to use this for rankings, seating arrangements, or passwords. I mean, a password of 1, 2, 3 is a totally different beast than 3, 2, 1, right? Now, over on the right side, combination. Order doesn't matter. You use this for team selection, forming committees, or tossing fruits into a bowl for a salad.
Listen, if you remember literally nothing else from this explainer today, drill this memory trick into your brain. Permutation equals position. Combination equals choice. If the problem is about giving things a specific position or rank, you are dealing with a permutation. If it's just about making a choice from a larger group, it's a combination. That right there is your ultimate exam day shortcut.
Let's prove that this works with a solved example.
Okay, imagine an exam question asks, in how many ways can you choose a committee of 3 men from a group of 7 men? First thing you do, pause and ask yourself, does order matter? No, it's a committee. It's a choice. So we are using combinations. 7C3. We set up our formula, 7 factorial over 3 factorial times 7 minus 3 factorial. That simplifies down nicely to 7 factorial over 3 factorial times 4 factorial. When you expand those numbers out and cancel the matching terms, you are left with exactly 35 ways to form that committee. Easy, right? Finally, part 6, exam tips. I've got to give you a massive warning about the most common traps students fall into during high-stakes tests like JEE and CUET. Do not forget to expand your factorials completely before you start canceling things out. Do not mix up the NPR and NCR formulas. Always remember that extra R factorial belongs in combinations. And most importantly, literally never start calculating until you've paused to ask yourself, wait, does order matter in this specific scenario? Let's move to and see how this builds into a complete mental map of today's explainer. We started simply with the counting principle of multiplying our choices, then we picked up the factorial tool to calculate arrangements super quickly. From there, we hit a fork in the road. If order matters, we take the permutation path. If order doesn't matter, we take the combination path. It's a beautifully logical flow from start to finish. You now have the exact toolkit you need to decode any crazy word problem they throw your way. But watching this explainer is just step 1. Here is my challenge to you. Go practice 10 questions today using this exact framework. Just 10. Do that, and I promise you, you will never forget permutations and combinations. But before you go, I want you to think about this. The next time you hit shuffle on a giant music playlist or try to crack a digital code, ask yourself, just how many millions of combinations are hiding right there in plain sight?